Voyager 1, NASA's most distant passenger spacecraft, continues its incredible journey through space, flawlessly transmitting incredible data from deep within the universe for nearly 50 years. This amazing space exploration has revolutionized our understanding of space. However, in recent years this spacecraft has returned disturbing information to Earth, shocking the entire space world. Are these alarming symptoms the result of a technical error or of the groundwork? Join us as we discover the truth behind these amazing exchanges. Since the beginning of recorded history, scientists have been fascinated by the mysteries that lie beyond our celestial boundaries. This interest led to the early launches of the space probes Explorer 1 and Explorer 2, among other spectacular space missions. These long-discussed milestones began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. The twins, each weighing 720 kilograms, were to a small craft, launched in a rare alignment of the outer planets. During their incredible journey, these intrepid explorers navigated different routes and speeds, reaching a critical moment on December 15, 1977, when Explorer 1 took off from its parallel trap. Due to course changes. Since then, Explorer 1 has become an invaluable resource, providing a wealth of information and revealing the secrets of space. Before diving into Explorer 1's amazing new discovery that surprised the entire space industry, let's review the incredible images captured by the rocket's 1978 Jovian axial imaging mission. Explorer 1 is 265 million kilometers from Earth. From this point, many images are sent back to Earth. In January 1979, the 100-hour project began, recording an impressive time-lapse film showing 10 revolutions of Jupiter. With 3,750 images we can see Jupiter's beautiful dance in vivid detail. Months later, Explorer 1 wandered into the Jovian moon system and made a surprising discovery, the presence of a small ring around Jupiter and 2 new moons, increasing its let's get to know the beautiful planet of Jupiter. Adjustments were made to ensure a safe approach and avoid a collision with Titan, one of Saturn's moons. Probe 1 continued its orbit around Saturn and discovered 4 more moons, Mimas, Enceladus, Tethys and Rhea. At the end of the Saturn mission, the scientists decided to end the planetary mission of research by pushing Explorer 1 and 2 beyond the borders of our planetary system, going measured 200 million miles, 325 million kilometers, in January 1990. Another chapter. Launched, the Interstellar Research Mission. During this time, Explorer 1 produced some of the most famous images in history, including the Sun and most of the planets. One person who played an important role in expanding the missions beyond their original goals was the famous astronomer Dr. Carl Sagan. As part of the mission's imaging team, Dr. Sagan struggled to take one last set of images as a parting gift to humanity. In any case, its great potential paid off on February 14, 1990, when Explorer 1, 6 billion kilometers from the Sun, began a visual journey known as the birth photo of a planetary group. These amazing images, 60 in all, added to the spacecraft's impressive collection of 670 images. When Voyager 2 encountered Neptune, Voyager 2 managed to record the wind speed of more than 1,300 meters per second, making it the fastest wind recorded in the planetary zone. When the rocket came within 280 miles of Neptune's blue methane gas, we got an amazing view of this distant celestial body. Interestingly, Neptune's largest moon, Triton, was found to be one of the coldest people in our planetary group, with a surface temperature of a measly 391 degrees Fahrenheit. Triton's unusual features, such as its gas-spitting ice volcanoes that propel ice particles up to 5 miles into the nebula space, also captured our imaginations. These amazing discoveries have expanded our understanding of the incredible diversity and complexity of celestial bodies in the farthest reaches of our planetary system. But don't go anywhere, Rocket Explorer 1 has made one of its most terrifying discoveries. But first, let's understand what has been achieved in the last 45 years. The achievements of the 2 Explorer studies are not unusual. More than 40 years ago, their first observations of the moons of Jupiter and Saturn surprised scientists and overturned previous ideas about these distant worlds. Once thought to be sleepy and shadowy like our moon, these moons have been found to be packed with terrestrial activity. Explorer 2 accomplished some remarkable feats during its journey. The Space Shuttle made history in 1986 when it was the first vehicle to fly past Uranus. Just 3 years later, he accomplished another amazing feat by transiting Neptune. So far, this is the only rocket that has followed that path. As the Explorer rockets continue, NASA has taken several steps to extend the life of the project. In recent years, components and heaters that are not necessary to conserve energy have been eliminated, ensuring that these bold studies can continue their projects into the next decade. The estimated date for the end of their mission is set for 2030. For the scientists and engineers who have been involved in this amazing project from the beginning, the end of the research project is a moment of pride and feeling sad. Their commitment and hard work has exceeded their expectations. The amount of data returned by the research has provided great knowledge, great scientific discoveries, and stimulated the imagination of many scientists and space enthusiasts. Explorer 1 and Explorer 2 are not just space probes. It was carefully designed as a stable platform with a rotation speed of more than 15 times slower than 1 hour. This design decision reduced the field of view as the spacecraft captured images and data as it traveled through infinite space. Even before their encounters with exoplanets, their amazing imaging capabilities amazed scientists and the public alike. The spacecraft began sending images of Jupiter before it entered the atmosphere. These early images, showing swirling clouds and the Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that caught our attention. Io, slightly larger than Earth's moon, was found to be the most volcanic body in the solar system. The spacecraft's instruments detected different signals from Io, confirmed by their shape. High volcanic columns were seen with the surface formed by the eruption of the volcano. One of the most famous volcanoes, Io, is 10 times as powerful as Mount Saint. Although the spacecraft's cameras were turned off to conserve power and memory before entering interstellar space, it turns out that the images they captured did not include Mercury and Mars for some reason. In addition to the interstellar probes Explorer 1 and Explorer 2, NASA has also operated other famous spacecraft such as Voyager 10, Voyager 11, and New Horizons. Explorer 1 flew past Voyager 10 on February 17, 1998, making Voyager 10 the most distant spacecraft. Probe 1 continued its solo journey for another 14 years before entering interstellar space on August 25, 2012. Although no spacecraft were able to observe it, NASA shared this amazing feat until 2013. What conditions have ensured the success of sound missions? A very simple method: the auxiliary functions of energy. These efforts were instrumental in propelling Explorer 1 and Explorer 2 on their daring missions to explore the outer reaches of the universe. 2. Get to these distant places and collect valuable data. Spacecraft need more than their simple propulsion systems, they need lift and the help of energy. Imagine two intrepid rockets, Voyager 1 and Voyager 2, starting their epic journey through the local planetary system. Instead of relying on their own machines, they engage in a celestial dance with some of our local planets. The heavy planets formed a dancing group, using the energy of these giants to propel themselves. This method allows them to save a lot of fuel and quickly reach different places. Examining the principles of the gravity sling, known as the gravity sling, we can see that the idea behind this operation is to transfer some of the Earth's energy to the spacecraft while as he goes. Imagine that Explorer 1 is approaching Jupiter, which has a huge atmosphere that has the same gravitational pull. Explorer 1 moved with precision through Jupiter at speed and angle. Jupiter's force pulled the spacecraft, increasing its speed and boosting it. It's doing a great job helping out, and it's really important. If Explorer 1 approached Jupiter at the wrong angle or speed, the inclination deviation could have been caused by the negative rotation from its orbit. The level of precision required is daunting. However, the geniuses behind these missions have often implemented these powerful assistants, guiding the Explorer spacecraft on a remarkable journey through the local planetary system. For example, Probe 2 used Jupiter and Saturn craft to reach Uranus and Neptune. These weather events are essential to making the great journey possible. Observation missions have had a lot of success with these active aid efforts.